Hello, welcome back guys. So in this lecture, we'll talk about a little bit of logarithms. Because the reason of me recording this lecture is because in future lectures, at some point you will encounter some big O expressions of some algorithms which are not straightforward like O of n square, O of n and big O of 1, right? These are the most common and simple ones. So in some cases, you will encounter the logarithmic time complexities. And to understand that, you have to at least be aware of what logarithms are. Okay, so in this lecture we are not gonna dive deeper into logarithms. We will just get the basic understanding like what are the logarithms and how they work. Okay, because we just worry about the bigger picture, right? So even if you have learned it at some point and you forgot it all, that's also fine. And if you haven't even learned it ever, then also we are just going to get the basic understanding. Okay, so that in future lectures, in case if we encounter any logarithms related time complexities, then at least we can understand what's going on there, right? So let's start with the logarithms. Like, what are logarithms? So logarithms are basically the inverse of the exponentiations, right? So the way multiplication and divisions are the pairs, right? The same way logarithms and the exponents are the pairs. Okay, so as you guys can see my screen, let me quickly zoom out a little bit and let me just stretch it because this one we'll discuss a little bit later, right? So as you can see my screen, we have log base 2 and then we 8, right, which is giving us 3, right? So what we can say is like log 2 to the power what gives us 8. Okay, so if we divide 8 by 2, let's say if we divide 8, let's say we divide it by 2. Okay, so it will give us like 4, right? Or better, I'll write it here itself. If we divide 8 by 2, then it will give us 4. And then again, if we divide 4 by 2, then it will give us 1, right? Sorry, 2. Right. And if we divide 2 by 2, then it will give us 1, right? So now we are getting a value which is smaller than or equals to 1. Right now we are getting a value which is 1, right? So that means we have to count these 2's. So 2, 1, 2 and 3. So what will be the log? The answer will be this one, right? So this is how we calculated. We just divide the number by 2 and then c, and then we divide it until we get a number which is smaller than or equals to 1, right? And as soon as we get that, we just count how many times we divided it by that number, and then we write it this way. Okay, so 2 goes here, and then the number which we are dividing goes here, and then how many times we have divided it with that number, it goes here. Okay, or we can write it like this as well. See, 2 to the power what I have mentioned, right, gives us 8. So 2 to the power 3 gives us 8, right? So we can write it like this as well. 2 cube, if you multiply 2 3 times, like so, like 2 into 2 into 2, then also it will give us 8, right? So that is why we say logarithms are the inverse of the exponents. Okay, so let me just quickly write it here. I think this one you guys will understand, but still for a reference I'll write it like this. Okay, so this way we calculate the logarithms. Okay, and it's not necessary every time you have to pass 2. Okay, so this 2 we pass to call it binary algorithms. These are called the binary algorithms. It can be 5 as well, it can be 10 as well, it can be whatever, right? Now so this is how you can understand it. So we have log base 2 and then we pass a value. Okay, and then on the right hand side of the equals to we have exponent, and this is how we can write it. 2 to the power exponent like this too. Let me just zoom it a little bit more so you guys can see. Okay, 2 to the power exponent will give us the value which we have here in the logarithm, right? So the exponent goes as a power of this 2, and then this value goes to the right hand side, right? It is the same way of writing these things, as you can see. Okay, so in simple words, like 2 to the power what, like 2 to the power what gives us 8. Okay, so 2 to the power 3 gives us 8, right? So that 3 goes, this 3 goes on the right hand side in the logarithm, and then this 8 goes to the left hand side and it gets multiplied with this 2. Okay, so this is how logarithms work, and we just care about the broad trend, so we are going to omit this 2, right? Because it's difficult to write this 2 every time, in at least in VS Code, right? This is called, I think, subscript, right? And in case if you really want to write the subscript and superscript like this one, then I have installed one extension. Let me show you quickly. Okay, so this one you can make use of it. Okay, markdown superscript. So you can install it. I think it's not this one. Okay, it's this one. Sorry guys. Yeah, so this one you can install it, and how this works, as soon as you install it, then what you have to do, let's say I want to make it as a subscript. So I'll select this number. In Mac, how it will work, like I have to press Command Shift and P, and I'll search for, let's say I want to make it superscript. Okay, so I'll search for superscript. Okay, here you will get something like this, and see, I made it as a superscript. Same way, if I want to make it as a subscript, I'll select Command Shift P and I can make it as a subscript, right? So in Windows, it will be, I think, Control Shift and P, if I'm not wrong. Okay, so this way you can make superscript and subscript, but this is not necessary. I just wanted to show you that extension, which can be helpful for you guys for your like future things. Okay, so this actually doesn't matter for us because we are going to omit it. So let's say whenever we are talking about log base 2, then we'll be simply talking about log. Okay, so this is how we represent it. Okay, so from now onwards we'll say like log base 2, it will be equivalent to log for us. Okay, because we just care about the broad trends, we don't care about these base values. Okay, so now let's talk about a little bit clearer definition of log. Okay, so logarithm is a number that roughly measures the number of times you can divide that number by 2. Okay, and before you get the value that's less than or equals to 1. So this is what we have discussed. This is a number, we have divided this number by 2 until we get, let's make it normal 2, until we get 1. Okay, as soon as we got 1, we counted this number, like how many times we have divided this number. So this is what we are getting here, right? We have divided this 8 3 times, right, by 2. So we'll write 3 here, and which value we have divided? This one. So we'll write it like this, and with what value we have divided? With 2. So the base value will be 2. Okay, so this is the definition, until or unless we get the value which is less than or equals to 1. So here we got 1. So that is why we stopped dividing it. If we get something smaller than 1, then that is also fine. But yeah, high level overview, this is how we are going to get it. Okay, this is how we basically calculate the logs. Okay, so yeah, now why I'm like discussing about the logarithms in the first place, right? So that is the question right now. So I have a reference open here. I'll give the link of this in the description as well. So every time, like when we talk about the log expressions, you can open it parallelly to check like the complexity of that expression. Okay, and like how it is performing. So as you can see, log, we have some expressions which have log n, right? So it's also pretty good. At least compared to big O of 1, it is somewhere it is good, right? So it is coming in the green section. That means obviously it is the good one expression. So we have something else like here. Yeah, here it is. Okay. So here we have n log n. At least this n log n is way better than log of n square, right? Because this is quadratic time, right? It will take quadratic time. So at least this n log n is way better than log n. Okay. So this way, when we talk about log n, then you can quickly understand like what is the time complexity, like what is the performance of this algorithm. Okay. So if something have a big O expression of log n, then at least with this chart you can refer this chart and you can understand like where this code, this algorithm stands, like what's the performance of this algorithm. Okay. So you can keep this chart open with you whenever we are discussing about any algorithms or something, some sort of stuff where we include the big O expressions. Okay. So now why, like where we will encounter those log n big O expressions. Okay. So we'll encounter in some searching algorithms, we'll encounter in some highly performant sorting algorithms as well. Okay. And sometimes we'll encounter those logarithmic expressions, big O expressions in the recursion as well. Okay. So that is why it is quite important for you to understand, like to get at least a basic understanding how the logarithms work. Okay. So yeah, this is it for this lecture, guys. See you in the next one.